Hello, everyone. I'd like to thank Jeeny, Bractlet, and Codesmith for sponsoring this Tech Talk. My name is Zach, and I've come to you today to talk about web servers. So what is a web server? Think of it as a kitchen where a chef, the server, prepares a dish, web page, for the customer. When a customer enters a restaurant and orders a dish, the chef receives the order and prepares it in the kitchen. Once the server has finished preparing the dish, it is delivered to the customer's table, or they may receive a message from the chef stating that the dish is not served at this restaurant. Web servers are an essential part of the internet that enable users to access web pages and applications. When a user enters a website's URL in their browser, the browser sends a request to the website server to fetch the web page. The server then retrieves the requested web page from its storage and sends it back to the user's browser for display. The server may also be asked to retrieve data from a database and to run some form of calculations as well. Web servers use several protocols to communicate with clients, including HTTP, which is the primary protocol for exchanging data between clients and servers on the internet. HTTPS is an encrypted version of HTTP that ensures secure communication between the client and server. Web developers use web servers to deploy and serve the web applications to users. So these web servers provide a range of features, including reverse proxy functionality, load balancing, security, as the users can only see the reverse proxy, caching of commonly requested resources, compression between itself and clients to reduce load times, scalability, and additional performance optimization to help developers create fast and reliable web applications that can handle dynamic content generation and reduce website bounce rates. So what is a reverse proxy? Well, a reverse proxy is a type of server that sits between a client and server, forwarding client requests to the appropriate server and returning the server's response to the client. The reverse proxy essentially acts as an intermediary, providing an additional layer of abstraction between the client and the server. In a restaurant analogy, a reverse proxy can be compared to a waiter who stands between the customer and the kitchen. The waiter forwards the customer's orders to the chef and returns the dish to the customer. One of the key benefits of a reverse proxy is that it can be used to enhance performance and security by sitting between the client and server. The reverse proxy can intercept and filter requests, blocking malicious traffic and reducing the load on the server by caching frequently requested content. But what about a load balancer? Well, a load balancer is a piece of software or hardware that distributes incoming network traffic across multiple servers or resources with the goal of improving performance and availability and the scalability of applications and services. Load balancers work by receiving incoming network traffic, analyzing it, and then sending it to several servers in a cluster or pool that are capable of handling this request. By doing this, load balancers help to prevent any one server from becoming overwhelmed with traffic, which can lead to slow response times or even downtime. A load balancer is like a sous chef who distributes tasks among the kitchen staff. Sous chef ensures that each chef has the necessary ingredients and equipment to prepare their dishes. Overall, reverse proxies and load balancers are important tools for web application developers and often are bundled together into a single web server. Looking at this chart of web servers, we can see that clearly the top two web servers comprise of Nginx and Apache, and a close contender in third is Cloudflare. Combined market share of 86% is held by the top three. So let's take a deeper dive into the top two web servers, Nginx and Apache. Both web servers fall under the category of Layer 7 load balancer. A Layer 4 load balancer would operate at the transport level, managing DNS, mail, TCP, and UDP traffic, whereas the Layer 7 would operate at the application level and examine the content of the traffic itself, such as the HTTP headers or even application data. Apache was released on December 1st, 1995, and started off as a basic web server, and over time, modules have enabled it to have the reverse proxy functionality. Nginx, on the other hand, was released on October 4th, 2004, to outperform Apache by supporting a higher concurrency, and to a large extent it has. And it's about 2 times faster, and it's simpler to set up than Apache, especially with static files. And Nginx has been more popular in the container space as well. Though Apache is rooted as a more extensible server with its module support, and therefore has cases where it can perform some web server functions natively compared to Nginx, which has to use external processes to handle dynamic content, for example. But it's not an either or choice, as they can be chained together, where an Nginx reverse proxy can point to an Apache web servers, and those web servers can point to even other servers. Both Nginx and Apache have implemented event-driven architecture, which I shall refer to as EDA from here on, to enhance the performance and scalability. EDA is an architectural pattern that focuses on the production, detection, and consumption of events. Events can be any occurrence that requires a response, such as user actions, system events, or messages from other systems. In EDA, components communicate through events, enabling decoupled and asynchronous processing. In Nginx, an event-driven architecture is used to handle multiple connections simultaneously while blocking other connections. Nginx uses an event-driven and asynchronous model to achieve high performance and scalability. For example, when a new client connection is accepted, Nginx adds it to the event loop and processes events as they occur. This approach allows Nginx to handle thousands of concurrent connections without blocking. Similarly, Apache has implemented an event-driven architecture through its MPM, its multi-processing module worker, and event models. These models handle incoming requests using a pool of child processes or threads, each of which can handle multiple connections. The event-driven model allows Apache to handle a large number of concurrent connections while maintaining high performance. EDA has become a popular architectural pattern for high-performance systems like web servers. Both Nginx and Apache have implemented this pattern to achieve scalability, performance, and reliability. What about CDNs? And what even is a CDN? And how does it tie into everything before? Well, a CDN is a distributed network of servers that cache and deliver static and dynamic content to end users from the server closest to them. By doing so, reduces the latency and improves the response time of your web applications, thereby enhancing the user experience. You can compare a CDN to a franchise restaurant, wherein the franchise is composed of multiple restaurants in different locations, so that each customers can acquire their favorite meals, content in this case, in a sensibly short amount of time, regardless of where they are physically. When it comes to using a CDN of web servers like Nginx and Apache, Cloudflare is one of the most popular choices. Cloudflare acts as a reverse proxy in front of your web server and caches content on its edge servers across the globe. One of the main advantages of using Cloudflare with Nginx and Apache is they can help you to mitigate DDoS attacks, reduce spam, prevent other security threats. Cloudflare provides security features like SSL and TLS, encryption, firewall rules, and rate limiting, which can help to protect your web server from malicious traffic and attacks. Moreover, Cloudflare can help you also optimize your website's performance by minifying static assets, compressing files, and leveraging browser caching. This can help you to reduce the load on your web server and speed up the delivery of content to end users. In terms of compatibility, Cloudflare works seamlessly with both Nginx and Apache web servers. In conclusion, web servers such as Nginx and Apache, as well as content delivery networks like Cloudflare, are crucial components of the modern internet ecosystem. They provide the backbone for delivering content quickly, efficiently, and securely to users around the world. Whether it's serving up static files, processing dynamic requests, or mitigating DDoS attacks, these technologies are essential for ensuring that websites and web applications are fast, reliable, and accessible. As the internet continues to evolve, we can expect these technologies to play an even more important role in shaping the digital landscape of the future. Here are my resources. And you can connect to me via LinkedIn and GitHub. And thank you for listening.